Hello, welcome back to 8-3. This is example 3 of that lesson, the accumulation of rate in, rate out, a commonly seen FRQ on the AP exam. We're going to go ahead and look at this example and solve some of these questions. So example 3, they say the number of a particular species of rabbits in hundreds in a wooded area is modeled by a differentiable function r of time t, where r of t is the number of rabbits in hundreds, and t is measured in months. From 0 to 50 is our domain. There are 1,500 rabbits in the wooded area at time 0. The birth rate for the rabbits is modeled by, so here we have birth rate in hundreds of rabbits per month, and then the death rate of rabbits, the death rate in hundreds of rabbits per month. Okay, so let's go ahead and go over this and talk about what they give us. Well, right here, they give us the initial value. So when we start measuring, there is 1,500 rabbits at time 0. Okay, so you can think about this a couple of ways. They're saying r of 0 is equal to 1,500, right? Or you can think about it as a point, 0, 1,500. And then they say, here's the birth rate. Okay, this is the rate in, right? If we have birth rate, rabbits, it's going to increase. And then the death rate. Here are rabbits going out. Peace out. Rabbits going out. Okay, some other things that kind of strike me that I'm a little cautious about is whenever they say in hundreds, if they're ever multiplying by a certain value, you got to be careful about that. So we'll watch for a curveball there. And, okay, well, they give us some gnarly functions. This is going to be a calculator active problem. Anything like this, like that death rate, it's going to cause a death rate amongst myself, maybe you guys. We're going to use calculator for that. So it's not too heavy, but that's pretty gnarly, if it were, a regular function. Actually, this doesn't seem too bad, but no, this is calculator. Okay. A, is the population of rabbits in the wooded area increasing or decreasing at time t equals 0? The population of rabbits. So, well, I guess I kind of skipped something. What I want to do in these problems right away is I want to come up with a formula or a function for the rabbits. I'm just going to say r of t. What is r of t? The number of rabbits. So the number of rabbits, we're starting out with 1,500. Here's our initial value. And then we're going to add rabbits from 0 to t, whatever our input is, right? This is going to match from 0 to t. And then I want the birth rate. So here's our rate in because I'm adding this. This is going to be b of, I don't know why I'm curving up here, b of x dx. And again, I just switched the variables. I want those variables to be different. And then I'm going to subtract, here's the death rate, from 0 to t. I'm assuming that the death rate, yep, okay, from 0 to t, whatever that time is, and then of the death rate, dx, d of x dx. Okay. So there's our function r of t, and what I like to do in my calculator is I like to go ahead and quickly define these. So I'm going to go ahead, I don't have the paper in front of me or split screen, so I'm going to pause the video and I'm going to go ahead and define these. But go ahead, pause the video right now, you to do this with me, because I'm going to do this quickly, right? So define, I'm going to go ahead and define the death rate. I'm going to say this will be b of x. I'm going to put everything in terms of x. Okay, so b of x is equal to, go ahead and pause me, and this will be done in a few seconds. All right, so here is the functions defined. There's my functions defined, and what I'm also going to do right now too is I'm going to define the function r of t, the number of rabbits. So go ahead and define. I'm going to say, okay, r of x, or I could say r of t. Remember, in these I want the variables to match for my integrals. So r of t is equal to, I'm starting out with 1,500 rabbits, and I'm going to add the integral from 0 to t. Yeah, I want that to be the same as my input of b of x. So there's my function b dx, and I'm going to subtract now the integral from 0 to t d of x, the death rate. So morbid. Okay, so if you do this correctly, if your function input matches your upper limits on your integrands, and then these variables in your integrands are different than your input variable for your function, you should be fine. You should get a done. I want to define this function because I'm going to go ahead and I could possibly use it for like a maximum where I have to calculate lots of values. It's nice to have it stored, okay? So we put in some front work, right? We're already 6 minutes into this video. Ideally, this FRQ is done in 15 minutes. Short work, you haven't even looked at the first question. Well, here we go. Is the population of rabbits in the wooded area increasing or decreasing at time t equals 0? Well, the population of rabbits, remember this is r of t, and I want to know is it increasing or decreasing? And so what I'm going to look at is r prime of t, which if I look up here at r of t, what we defined, the derivative of this is just b of t minus d of t, and I want to know, is this greater than or less than 0? So I'm going to go ahead and evaluate, okay, what's r prime of 10, and this is going to be b of 10 minus d of 10, and I'm going to see, okay, what is this? Is this an increasing value or a decreasing value? So b of 10, we've already put in the heavy lifting, right, by defining that function, minus d of 10, okay, it's 1.818 equals 1.818. Okay, this is greater than 0, so therefore I know that it is increasing, right? So we can say the population of rabbits is increasing at t equals 0, sorry, t equals 10, because b of 10 minus d of 10 is greater than 0. There you go. B, to the nearest whole number, what is the population of the rabbits in the wooded area at time t equals 50? They want the population of rabbits at t equals 50. Okay, so this is r of 50. R of 50. Well, check this out. If you've already defined r, if you wrote this up here, like on your paper, you can just go ahead and plug in 50. If not, you're going to have to define this function. This is 1,500 plus the integral from 0 to 50 of b of x dx minus the integral from 0 to 50 of d of x dx. Okay, and if you put in t's there, that's not going to matter because it's not conflicting. But I would stay consistent of that structure. So you write that down. Luckily for us, we've already defined this and put this in our calculator. So we say r of 50. R of 50. We get 1,516.568288736. This is where that curveball in the problem says in hundreds. What's the population in hundreds? So I'm going to go ahead and I'm going to multiply by 100 to get the true population. You could say 1,516.568 in hundreds, potentially, but I like multiplying by 100 because I want to be accurate to 3 decimal places. Here we get 151,000 656.829 rabbits. And I know you're like, Schwarberg, how do you have 9/10 of a rabbit? You know, I don't know. Some were born a little funny. Okay, so so this is equal to 151. Well, how do I want to do this? I'm gonna say times 100. Times 100 is 151,000. What was our number? 656. What was it? 829. Yeah. Okay. So there's the amount of rabbits at time 50. And you could write a sentence. At time 50, the population of the rabbits at time t equals 50 months, the population of rabbits is 656.828 rabbits. There you go. Rabbits. Done. Okay. To the you don't have to though. They don't ask for a sentence in context. So right here, that would be suffice. Okay. 11 minutes. Ooh, to the nearest whole number, determine the maximum and minimum population of rabbits in the area for 0 to 50. Justify your answer. Okay. Here's what we're going to have to do. In order to determine an absolute or a global max or min, we need a table. I need a table. I need t equals, and then I need r of t over here. Okay, so t equals 0 and 50. Right away, those are going on my table because they're the endpoints. So you want endpoints, okay, and critical numbers. Now, this question was nice. They already gave us the amount of rabbits at time t equals 0. They said that was 1,500. Okay. 1,500. Oh, I see an issue on that last one. This is already not in hundreds, the 1,500. So I'm going to have to go back and adjust that last answer. And then 50, come on. 50 we calculated in the last problem. But I have an issue here. I'm going to have to go back and I'm going to have to redefine this because they multiplied this times 100. Okay. Wait, let me make sure. Okay, so here's what we're going to do. I'm going to take the 1,500. I'm going to take my initial value. And for r of t, I'm just going to go ahead and I'm going to divide by 100. That's going to cancel some zeros. So my initial value I'm going to use, since I'm going to multiply by 100, is 15. So let me go back to my calculator and let me edit my actions. Go back. Number 4. Okay, so I'm going to go menu, actions, and then you'll see recall definition. I'm going to recall my definition R. And I don't want R to be 1,500. I just want it to be 15 because I'm going to end up multiplying this by 100 times 100. Okay, so we get 3,100 and 3,156.828. Okay, so that was a tricky one. 3,000. I even told you guys too. I said, hey, watch out for this curveball. This is going to be 829. This is going to be a trick So let me make sure I have that value right. 829. Okay. All right. So this is 3,000. What was that number? 156.829. Okay. Now what I'm also missing is my critical numbers. So where is B of t equal, or sorry, B of t, because this is r prime of t, r prime of t. Where is B of t minus D of t equal to 0? I have to find that. So I'm going to go into my calculator and I'm going to say, okay, menu, algebra, I'm going to go ahead and solve where is B of x, you could use t, B of t minus D of t equal to 0, and I'm going to say comma solve for t. So where is this equal to 0? And my calculator tells me this value is way outside of our bounds. It looks like we have a couple of critical values. T equals 17.822, and this one 42.510. Okay, so I want those values, 17.828 and 282 and 42.511. Okay, and so I want to find out how many rabbits are there at those times. Okay, so let's say I'm going to plug it back into my calculator. R of 17.282. Okay, so I go ahead and plug that in, and then I'm going to multiply that number by 100 times 100. And we get 3,872. 3,872 point, what was this number? 808. And then 42.511. Okay, so R of 42.511. Okay, and that's times 100. 3,077. 808. So 3,077.808. Okay, so which of these is the max? Which of these is the minimum? We can say max, determine the maximum and minimum population. Maximum population of 3,872.808. Okay, and minimum of 1,500. All right. Whew. Okay. And then here, D, on which intervals for 0 to 50 is the population of the rabbits in the wooded area increasing? Give a reason for your answer. So here's what we're going to go ahead and do for this one. We're going to go ahead and graph. So I'm going to go Control, add doc. I need to add a graph. And what I want to go ahead and graph is R of, well, a couple of ways you could do this. Let's do some calculus here. So let's say D of x, no, B of x. B of x minus D of x. Go ahead and graph it. Here we go. And I want to know, where is it? So this is R prime, right? Here we go, R prime. And what I want to do is I want to say, okay, where is this positive? Because this is R prime, right? So where is it increasing? So I'm going to go ahead, clearly define my zeros. So analyze the graph. Intersection, no, not an intersection. Analyze the graph. I want zeros. And so my zeros tell me, hey, this is when it is equal to 0. Oh, I already know the zeros because we already found those, didn't we? In the excuse me, in the last one? I already found those. Menu, analyze graph, 0. It's gonna be 42 point, yeah. Okay, so I already found this. Okay, so when is the population increasing? Well, from 0 to 17.282 and 42.511 to 50. Okay, and we'll give an answer. So the population is increasing from 0 to 17.282 union 42.511 to 50 because r prime of t, which is equal to b of t minus d of t, is greater than or equal to 0. Okay, so there you have it. There is our answers. Okay, whew, that was a good one. Yeah, use those calculators and those ideas. All right, catch you in the next video.